In an area like this, and I'm no expert on steel making or coal, I can see a series of opportunities and also perhaps threats, depending on which way you look at them. I serve on the Sustainability Advisory Board for Siemens, a large German engineering company. One of my fellow board members is Jamshid Irani, who is he's just stepped down as chairman of Tata Steel. His view of steel making is that within a decade or so, the use of hydrogen as a reductant in the steel making process will be a technique that will be being deployed commercially. That particular process is being a lot of money invested in it, particularly in South Korea at the moment. The steel, he tells me, made by that process is superior to steel made in normal processes. And of course there are zero emissions from using hydrogen as a reductant in the steel making process. So there are, disruptive technologies like that that may come online, and I hope a region like this is at least giving some consideration to what a future might look like where hydrogen is the reductant used in the steel making process. Coal into the future, there will be a coal market, no doubt about it, for Australian coal for the next quarter century or so, which is probably plenty long enough for a lot of the industries involved. We know that because in places like China there's quite a lot of new build, quite a lot of new coal-fired power plants, and they're not going to be closed down tomorrow. But we can also see that there is going to be increasing demand for technologies such as carbon capture and storage. Australia has a good record of investing in that particular technology. It's still uncertain as to what sort of role it'll play in the future. But again, I just point to that as one of the technologies that are probably particularly relevant to a region like this. Maybe not in domestic coal-fired power plants, but in global deployment of that technology so that Australian coal can be burnt more cleanly overseas. There's also many other opportunities. I know here off Wollongong you've had a wave energy machine operating. I don't know what the present status of it is. Last time I looked, I think the buoy had sunk or something and it was having some troubles. But again, those sort of technologies will, I am reasonably sure, play some sort of role into the future in terms of energy. There's other experimental sorts of technology, wave-based technologies off Western Australia that look quite promising, as well as yet other configurations in places like Europe. So even on the doorstep of a place like Wollongong, you have opportunities to diversify right now, at least as an experimental basis, into a series of other industries. And I could just point out one thing Arthur Rorris taught me was that, of course, in the new clean energy space, there is going to be huge demand for steel. There's a lot of steel in a wind tower, and as the need for wind energy grows, so will the need for steel. And I guess that when we look at these things, we need to look at them in the complex, holistic way that life actually plays out, rather than think along single linear tracks. We need to sort of step back and have a look at that bigger picture. Having said that, I think there's really little more for me to do than wish you all well. I think Will Stephan is back now. He was out doing an interview. But thank you very much for inviting us to be part of the conference, and we'd be happy now to take questions. I might sit down and perhaps let you, Ellen, take the questions. Thank you.
If we could put the slide up that shows how to text and tweet. There you are. Okay, terrific. Love the centrepieces. There we go. Hands up if you love the centrepieces. Let me just tell you very briefly about the centrepieces. There's a little bit of information in the middle of each pot, but they're produced by a local enterprise, which you can read about on the back of the pot. And I'd encourage you to make them your Christmas presents. Aren't they terrific? That'll do about the centrepieces. Let's take the first question here, and then we'll come to some live questions from the floor. Please comment on the significance of water vapour, nitrous oxide, aerosols and global dimming. Do we have a sufficient understanding of the role of those? Do you want to take that one, Will?
Yeah, the answer...
We can hear you.
Okay. The answer is yes and no, depending on what you're talking about. Nitrous oxide we know very well. We can measure it. We know it's going up. We know where it comes from, and we know its impact on the climate. Water vapor, yes, that's actually a feedback. The initial warming driven by the greenhouse gases, CO2, nitrous oxide, methane, leads to more evaporation, primarily from the ocean. That puts more water vapor in the atmosphere. Water vapor is also a greenhouse gas, so we call it a reinforcing feedback. We understand that pretty well, and that's included in all the climate models. And when I showed you that line going up of the model projections and the observations for last century, that includes the water vapor feedback. The big unknown is really on the aerosols. Aerosols you would know as pollution, the haze you see over a city. Now that actually cools the climate because it scatters some of the sunlight that comes in and keeps it from getting to the surface and warming the surface. Less is known about the exact quantity of that effect. It is included in the models, but it has a big error bar around it. Most of the aerosols today are in the rapidly developing countries like China and India. Once they clean those up, and they will because it's a human health issue, that will actually increase the warming because it'll take away that masking, that cooling effect, and the greenhouse gases will have relatively more impact. So that's a quick science of those other gases and aerosols.
My goodness, there's a question here. Please keep indicating where the questions are and we'll get a microphone to you. Oh, if you'd like.
Hello, Monique Dare Ward from Kiama Council. In the media we're hearing a lot about the 5%, but we're also hearing from the scientific community that we've reached or passed many tipping points that are of concern. Could I please have anyone in the panel comment on particularly one of the tipping points that is most concerning? How close are we to the Northern Hemisphere's albedo flip? I think that's the term. And also, what impacts are likely to ensue for particularly coastal areas over the next few decades of the subsequent loss of the rapid loss of our ice sheets, such as the Greenland ice sheet and our Larsen ice sheet down in the south? I've heard that the sea level rises we're seeing on the media are eclipsed by the consequences of the loss of the Greenland ice sheet. So if you could explain that, please.
Right, the Northern Hemisphere albedo flip. I actually referred to that, but not in those words in my talk. And that was that graph, you remember, of the sea ice over the North Pole dropping quite rapidly. The consequence of that is you remove that nice white reflective surface over the North Pole, that cap. It acts a bit like a refrigerator for the planet. In other words, it bounces the sunlight back into space. Now, as that diminishes, what's underneath it is much darker ocean. And that absorbs much of the sunlight and increases the regional heating, which then causes more loss of ice, which increases the heating even further. That's the so-called albedo flip. We are actually, I think, reasonably close to that, and we could see it in a decade or two. That will intensify the warming around the northern high latitudes, which then, of course, will have a knock-on effect, although diminished around the rest of the globe. If you look, it's interesting, if you look at a global map of how and where the temperature is rising, particularly over the last decade, it's striking how much more is rising over the northern hemisphere, and particularly the northern high latitudes, than it is over Australia. So this is the onset of the so-called albedo flip up there. And yes, it's probably the first of the tipping points, and it may be reached in a couple of decades. In terms of the big polar ice sheets, I think there are limits on how fast you can actually break up a big ice sheet. There's a lot of inertia that holds that back. Most experts think that we won't go much over a meter this century. I think the big joker in the pack, so to speak, is not Greenland, it's West Antarctica. Because that ice sheet, which corresponds to 4 or 5 meters of sea level rise, is grounded below sea level. So it sits on land that's actually below sea level. So it can potentially be eroded from underneath by warmer water, and we just don't know how vulnerable that is. I think that's the joker in the pack.